Guys, welcome back to my channel. So today I am going to give you the Biostatistics 8th semester 2nd unit question and answers as per RGUHS. So these are the questions which I have took from the question bank of Biostatistics, and these are the 10 marks question which is asked through the second unit. So the first question was explain different types of hypotheses, explain type 1 and type 2 error, level of significance, and as well as p-value. So the second question, explain regression analysis and its application in the stability testing of pharmaceuticals. And the third question is explain with suitable examples of regression analysis and standard error of regression. And number fourth, explain null and alternate hypothesis, type 1 and type 2 errors, and as well as confidence interval. And question number 5, 6 and 7, same question as question number 1, that is explain different types of hypothesis and explain the type 1 and type 2 errors, level of significance, and p-value. So I'll start from the answers question of second unit. So these are the 10 marks. The first question, explain different types of hypothesis, explain type 1 and type 2 error, level of significance, and as well as p-value. So what is the hypothesis? Hypothesis is a tentative solution for a problem, and it is a specific testable prediction about research study, and it is very essential to the scientists to understand the meaning of the nature of hypothesis, and the hypothesis need to be clear, precise, and being capable for tested. So the hypothesis is a tentative statement about the solution of a problem where the term of hypothesis has been defined in a several ways. A hypothesis is a provisional formulation or a possible solution or a tentative problem for being faced by a researcher. So the types for hypothesis. So the types of the hypothesis are, there are two types of hypothesis, null and alternative, where the hypothesis is the explanation for the basis of limited evidence. So what is the null hypothesis? So the null hypothesis is a statement which states that there is no relationship between two variables, and also it states that there is no statistical significance between the two variables in the hypothesis. So the example for the null hypothesis, where no significant difference in the academic performance, and they are also known as testing for hypothesis by converting them into the null form. Mostly the researcher may reject the null hypothesis by showing that the outcome which is mentioned in the declarative hypothesis does occur, and it is the hypothesis that the researchers try to disprove or reject. So the hypothesis is that the consumption of a particular medicine reduces the chance of the heart arrest, where the null hypothesis will be the consumption of medicine does not reduces the chances of heart arrest. So the formula, that is H0 is equals to mu1 equal to mu2, where H0 or H0 is equals to null hypothesis, mu1 is mean of the population 1, and mu2 is the mean of population 2. So the statistical hypotheses are tested using the 4 steps. The first steps to analyze and the state of two hypotheses that can only one be right, where the second step is to formulate and analyze, then plan, which outlines the data which will be evaluated, and the third step is to carry out the plan and physically analyze the sample data, where lastly the fourth step is to analyze the result, either reject or null hypothesis. where the principle of null hypothesis is collecting the data from determining a chances of a collected data in the study of random sample, proving that the null hypothesis is true. So the second type of hypothesis is alternative hypothesis or alternate hypothesis. So the alternate hypothesis defines there is a statistically important relationship between the two variables. So the alternative or experimental hypothesis reflects that there will be an observed effect for our experiment. So it is a contradictory to the null hypothesis and denoted by H0 and H1, where in many cases the alternative hypothesis might be just the opposite of the null hypothesis. So for example, the hypothesis may changes the water level in the spring. Alternative hypothesis would be there was a change in water level this spring. So there are three types of alternative hypothesis: left trail, right trail and two trail. So the left trail, here it is expected that the sample portion, that is mu1, is less than the specified value, which is denoted by mu2, such that h1 equals to mu1 is lesser than the mu2, where the right trailed is represented at the same portion, that is pi is greater than the value which is denoted by pi naught. So the two trailed is, according to this hypothesis, the same proportion which is denoted by pi is not equal to the specific value which is represented by pi naught. So h1 is equals to mu1 equals to mu2. So the alternative hypothesis provide the researchers with some specific restatements and clarification for the research problem, and the alternative hypothesis is important as they prove that the relationship exists between the two selected variables and the results of the study conducted and relevant and significant. So the level of significance, this is the essential concept for the hypothesis testing and considered in the percentages, normally 5%. So the significance level is the maximum values of the probability of rejecting a null hypothesis when it is true. So usually it is determined in advance before the testing for hypothesis. For example, if you assume the significance level to be 5%, it means that the researcher is ready to take 5% risk to reject the null hypothesis when it is happened to be true. So the p-value, so the p-value is the level of marginal significance within the statistical hypothesis test, representing the probability of the occurrence of a given event, and the p-value is used as an alternative to rejection points to provide the smallest level of the significance at which the null hypothesis would be rejected. So a p-value is used in the hypothesis testing to help you to support or to reject the null hypothesis. Then the types of errors, there are two types of errors, type 1 and type 2. So statistically significant results cannot prove that the researcher's hypothesis is correct because of a p-value, which is based on making an incorrect conclusion regarding the or accepting the null hypothesis. So the two types of errors in that, the number one, type 1 error, where it means the rejection of null hypothesis which should be accepted. In other words, this is the error of expecting an alternative hypothesis when the results can be attributed to the chance. So the type 1 errors is known as alpha error or level of significance of the test. So consequently, a type 1 error will having a false positive. This means that you will wrongfully assume that your hypothesis testing has worked even it hasn't. So the type 1 is caused when something other than the variables affect the other variable, which results in the outcome that supports the rejection of the null hypothesis. So the type 2 error is referred as a false negative. This is an means of accepting the null hypothesis which should have been rejected. In other words, this is the error of failing to accept an alternative hypothesis when you don't have to advocate power. This error is known as beta error, and the type 2 error happens when you have inaccurately assumed that no winner has been declared between a control version and a variation, although there is actually a winner. So a type 2 error would be occurred if we accepted that the drug has no effect on a disease, but in the reality the drug is effective in more statistically accurate terms. So the type 2 errors happen when the null hypothesis is false and you have subsequently failed to reject it. So next question, that is explain the regression analysis and its application in the stability testing of pharmaceutical. So what is the regression analysis? So it is a statistical technique of estimating the unknown value of one variable, means dependent variable, from the known value of other variable, that is independent variable, is called as regression analysis. So if one provides of value that depends variable from one value to the independent value, the regression can only intercept that exists physically. That is, there must be a physical way in which the independent variable x can affect dependent variable on y of the basic. So the basic relationship between x and y is given as the formula y is equals to a plus b x, where y denotes the estimated value of y for a given value of x. So this equation is known as regression equation of y on x, which means that each unit changes x produces a change of b in y, which is positive for direct and negative for inverse relationship. And the regression lines is the line that best to describes the linear relationship between the two variables. It is expressed by means of equation of the form where y is equals to a plus bx. So the regression equation of x and y is x equals to a plus by. So the regression equation of y on x is y equals to a plus bx. So the regression lines and the coefficient of correlation is perfect positive correlation, perfect negative correlation, and as well as high degree of positive correlation, high degree of negative correlation. So the types and the methods to find the regression lines in that scatter diagram and method of least square. So the scatter diagram, this is a simple method but does not give an accurate lines. It is used to show the cause and the effect relationship between the two kinds of the data and to provide more useful information about the production purpose. So independent variable is placed on the horizontal x axis and the dependent variable on the vertical axis y. So then the paired observation x and y are plotted on the graph. It is a curve to straight line, then it is called as a line of regression, and there is said to be a linear regression between the variables. So if we consider two variables x and y, then there are two regression lines. So the line of regression of y on x gives most probable value of y for the given value of x or vice versa. So y equals to a plus bx, where x is independent variable, y is dependent variable, and b is slope of the line, a intercept. In the same way, when it is changes to x, x is a independent variable, y is independent, b is slope, and a is intercept. So the method to least square, where the regression equation of x on y is x equals to a plus by. So the regression equation on y on x is y equals to a plus bx. So, and the values of the a and b in the above equation are found to be method of least of square. So the value of a and b is the method of least of square. References: the value of a and b are found with the help of normal equations. So these are the two equations to find the value of least square. References: so this is the equation and this is the solution of a problem, which is an example for the regression analysis. So coming to the next, that is regression coefficients. So the calculation by the least square method are quite difficult when the values of x and y are large. So the work can be simplified by using this method. Regression coefficient can simplify the difficult from square least method. So it gives the value by which one variable changes a unit in other variable, as there are two regression coefficients. So similarly, the regression coefficient of y on x will indicate the value by which the y variable will change to a unit which changes the value of x variable. So the regression equation on x on y equals to x minus x bar, which is equals to b into xy, where y minus y bar, and the regression equation y on x, similarly y minus y bar equal to byx into x minus x bar. So the formula and the equation for the regression equation on x on y and y on x. So this is the example for regression coefficient and the solution for a problem. And the next is multiple regression. So the multiple regression analysis is used for the predicting of unknown value of a variable from the known value of two or more variables. It is a model with one dependent and two or more independent variables. So the variables whose known value is to be predicted is known as a dependent value, where the variable whose value are used for the prediction are called an explanatory or independent variable, where it is used to calculate the dependent variable using more than one independent variable. So the multiple regression equation y on x, which is x1, x2, x3 till xn, which is given by y equals to a plus b1 into x1 plus b2 x2 plus b3 x3 till bnxn. So y equals to dependent variable, a is the intercept, whereas same for the b value, that is b1, b2 and b3, and the multiple regression equation is used to handle the multiple inputs, which instead of only one input in the linear regression. So the multiple linear regression is used to determine the mathematical relationship among a number of random variables. It is used to study the relationship to multiple independent variables to one dependent variable. So it is widely used in the biological, social and pharmaceutical sciences to study the possible relationship between the variables. So the multiple linear regressions are which provides and measures overall which is fit. Then standard error of regression. So the standard error of regression is S, which is also known as the standard error of the estimate, that represents the average distance which is observed value and from the regression line, where it is the measure of variation of an observation made around the computed regression. Smaller values of standard error of regression indicates the observations which is closer to the regression lines. So the standard deviation which measures the variation in the set of a pharmaceutical standard where y from the predicted value from y from the regression line, standard error of estimate is valid for the linear as well as non-linear regression models. So it is important in the calculation of confidence interval as well as prediction intervals. So the standard error to estimate and calculated formula which is SYX equals to root of summation x minus ye divided by n whole square. So the large value of x, yx or sxy, the greater of the scatter on the line of the regression. In such a case, the degree of correlation between the series is poor. And the confidence interval, say x bar is the sample mean from a random sample of the size n drawn from normally distributed population. But because a sample in flocculation, x bar can't be expected to an equal of mu. So sampling distribution of x bar for a normal population is follows as the formula. And this is the example for a confidence interval problem as well as the solution for confidence interval. And the applications in the regression analyst of the stability testing for pharmaceuticals. In that, number 1, regression is often used in the pharmaceutical research to determine how many specific factors are related with each other and to know their level of interactions for the desired outcome, where it is important for predicting and solving the issues to target the properties and the desired feature, where study of drug dose and response relationship over time in clinical trials for fitting the linear portion of pharmacokinetic data to compare the action of 2 or more different drugs or different doses of a same drug are studied using a statistical method. So in that, the next one is standard error of mean, SEX equals to SD divided by root of n, where SD is the rho and root n as well as. So the rho is standard deviation for the mean population and n is the size of the sample. So the example for the standard error of mean, calculate the standard error of mean of the tablets that not passes the test dissolution which are collected from 10 different batches out of 20 tablets. So the number of tablets and the solution for this is given as follows. So here I have completed the 10 marks question and answers of Biostatistics unit 2nd. So please do like, share and subscribe to my channel.